And they say, well, what's new? What did you find out that we didn't know before? And of course, the big answers are the first galaxies grew differently than we expected, and we don't know why their old predictions were wrong.
Has the James Webb Space Telescope just discovered a whole new type of star? This groundbreaking discovery could rewrite everything we thought we knew about star formation. And it's just the beginning. Webb wasn't just built to take breathtaking pictures. It's a time machine, an engine of discovery designed to answer our biggest questions about the universe. But in that quest, it stumbled upon a brand new, profound mystery. And it's not a weird galaxy or a strange black hole. It's something that might just challenge the definition of a star itself. These aren't just faint, distant lights. They're objects so bizarre, so completely against what we expected, they could force us to rethink the fundamental story of how stars are born and how they die. The data streaming back from Webb's golden eye is painting a picture of the cosmos that's far stranger and more complex than we ever gave it credit for. So what on earth, or off it, did Webb find that could unravel everything we thought we knew? Before we get into this cosmic rabbit hole, let's set the stage. The James Webb Space Telescope, or JWST, is an incredible piece of human engineering. From its vantage point a million miles from Earth, its giant gold-coated mirror and ultra-sensitive instruments see the universe in infrared light. And that's the key. Infrared is the light of heat. It can pierce through the dense cosmic dust clouds that hide stellar nurseries. And it's the ancient light that has traveled for billions of years from the first galaxies, stretched out by the expansion of the universe itself. For decades, we've told a pretty solid, elegant story about how a star is born. It starts in a huge, cold cloud of gas and dust, a nebula. Gravity, the universe's master sculptor, slowly pulls this material into dense clumps. As a clump collapses, the pressure and temperature at its core just skyrocket, until, finally, it gets so hot and dense that nuclear fusion kicks in. Boom! A star is born. This stellar engine then burns for millions or even billions of years, fusing hydrogen into helium, creating the light that makes life possible. A star's fate depends on its mass. Smaller stars, like our Sun, eventually puff up into red giants before shedding their outer layers and chilling out as a dense, cooling ember called a white dwarf. More massive stars live fast and die young, ending in a spectacular supernova explosion that leaves behind either a super-dense neutron star or a black hole. This is the textbook story, polished over a century of observation. Astronomers figured JWST would add some color and detail, maybe capture star birth with a bit more clarity and fill in some gaps. What they didn't expect was for Webb to send back data that suggested entire chapters of our cosmic storybook might need to be torn out and rewritten. It turns out, the universe has a few plot twists we never saw coming. The first clues that our story was incomplete came not from the edge of the universe, but from our own galactic neighborhood, in the stellar nurseries where stars are made. One of the first places Webb looked was the Serpens Nebula, a star-forming region just 1,300 light-years away. For years, a nagging problem in star formation theories was something called the conservation of angular momentum. Basically, as a gas cloud collapses, it should spin faster and faster, like an ice skater pulling in their arms. This spin should be so intense, it stops a star from ever fully forming. So how do they do it? The leading theory was that the young star must blast some of this momentum away in powerful jets. We'd seen hints of this, but JWST delivered the first direct, crystal-clear evidence. It saw a group of newborn stars all shooting out powerful jets in the exact same direction, perfectly aligned with the nebula's magnetic field. These jets, which look like fiery red streaks in Webb's infrared vision, are shock waves from material being fired off at incredible speeds. This was a stunning confirmation of the theory, but it was the sheer perfection of it that was startling. It was like building a dinosaur from a few bone fragments and a good idea, only to then find a perfectly preserved fossil that matched your theory exactly. It was a beautiful moment for science, but it also hinted that star birth was way more organized than our messy models predicted. Then, Webb aimed at another star nursery, the Cat's Paw Nebula, or NGC 6334. Here, behind curtains of dust, Webb's infrared eyes found something remarkable. Inside the nebula were dense little knots of gas and dust that astronomers charmingly nicknamed toe beans. Inside these cosmic beans, jwst found clusters of brand new stars, actively carving out their homes. We could see protostars glowing, their outflows pushing away gas and their radiation lighting up the cavity walls. What was truly shocking was how fast and dynamic it all was. We used to picture star birth as this slow, majestic process. Webb showed us it's more like a cosmic fireworks show, fast, chaotic, and over in a flash. The puzzle pieces were starting to form a pretty wild picture. Our models of star birth weren't necessarily wrong, but they were like a kid's coloring book sketch of a process Webb revealed to be a photorealistic, high-definition, and often violent masterpiece. Star formation was faster, more chaotic, and more efficient than we ever knew. But this was just the warm-up. The truly bizarre discoveries were still to come. As Webb kept scanning the cosmos, it started finding things that didn't fit into any of our neat little boxes. These are the celestial oddballs, the misfits that exist in the gray areas of our knowledge. To get how weird this is, we first have to talk about failed stars, also known as brown dwarfs. They form from a collapsing cloud of gas, just like a star, but they never get massive enough to kickstart sustained hydrogen fusion. They're bigger than Jupiter, but smaller than the tiniest stars. The universe's in-betweeners, or so we thought. Then came the observations of a star-forming region called NGC 1333. Peering deep into its dusty guts, Webb found something wild. It spotted at least 6 objects with masses between 5 and 10 times that of Jupiter. That's planetary mass. But here's the kicker. These objects weren't orbiting any star. They were just floating free, cosmic orphans. This immediately raises a huge question. What are these things? Are they planets that formed normally and then got violently yeeted out of their solar system? It's possible, but Webb's data suggests a far stranger and more exciting answer. These rogue worlds seem to have formed the same way stars do, from the direct collapse of a small gas cloud. They are among the least massive objects ever found that seem to have formed like a star. This is where our definitions completely fall apart. What do you call an object born like a star, but with the mass of a planet? It blurs the line between planet and star until it's almost meaningless. It's not really a planet if it doesn't orbit a star, and it's not a brown dwarf if it's not massive enough. We don't have a word for it. This is the heart of the new star mystery. We're finding things our cosmic dictionary has no entry for. But Webb wasn't done messing with the stellar life cycle. It also looked at the very end of a star's life. When a star like our Sun dies, it's expected to swell into a red giant and then collapse into a white dwarf, a hot, Earth-sized core of super-dense matter. For ages, the assumption was that this violent end would destroy any nearby planets, or at least fling them away. A planetary system couldn't survive the death of its star. Webb has found compelling evidence that actually, they can. By analyzing the atmospheres of white dwarfs, astronomers found them polluted with elements like magnesium, iron, and oxygen. These heavy elements should have sunk into the white dwarf's core, so their presence means they must be constantly raining down from an external source. The most likely culprit? The pulverized remains of asteroids and planets from a surviving planetary system, still orbiting the dead star and being slowly devoured. This discovery completely changes our view of what happens after a solar system dies, and it has huge implications for the ultimate fate of our own. From objects born like stars with the massive planets to planets orbiting the corpses of stars, Webb is systematically dismantling our neat categories and forcing us to embrace a much weirder, more interesting cosmos. So let's just ask the question. With all this mind-bending new data, has the James Webb Space Telescope actually discovered a new type of star? The short, official answer right now is no. There's been no confirmed discovery of a fundamentally new class of star, like one powered by something other than nuclear fusion. The headlines you might have seen about stars powered by dark matter, for instance, remain highly theoretical, though JWST has identified 3 intriguing candidates that fit the profile. But that official no is almost misleading because it misses the real revolution that's happening. The shocking discovery from Webb isn't one new kind of star. It's the realization that the universe isn't made of discrete, easily labeled things. It's a messy, continuous spectrum. The rogue worlds in NGC 1333 are the perfect example. They're not stars, they're not planets, they're not brown dwarfs. They are a new category of object that now needs a new definition. So while it may not be a new type of star, it is a new type of something, an object our theories didn't make room for. This is the real shift in thinking. We're being forced to toss out our rigid classification system. The universe is less like a set of tidy boxes and more like a painter's palette, where all the colors blend together. The phrase "new type of star" has become a kind of placeholder for these objects that live in the twilight zone of our understanding. Webb's superpower is that it can see the whole cycle. It can watch the chaotic birth of stars in nebulae like Serpens and Cat's Paw, revealing the violent forces at play. It can spot the strange, line-blurring failed stars or superplanets like the rogue worlds. And it can see planets orbiting the ghosts of dead stars. For the first time, we can map the entire cycle of star birth, life, death, and rebirth across a galaxy. And we now know this cycle includes all of these bizarre, unclassifiable objects we're just beginning to find. The discovery isn't one thing, but a whole new way of seeing. We thought we were just filling in the details of a story we already knew. It turns out Webb is introducing entirely new characters, forcing us to rethink the plot from the beginning. These discoveries are happening right now. New data and new mysteries are emerging from the James Webb Space Telescope almost every week. We are living through a complete revolution in our understanding of the cosmos. If you want to stay on the cutting edge of what we're learning, and you don't want to miss the next big discovery, make sure you subscribe and ring that notification bell. You won't want to miss what Webb finds next. In the end, the James Webb Space Telescope hasn't given us a simple answer or a neatly packaged new star. It's done something far more important for science. It has gifted us a profound and beautiful new set of problems. It has torn down our assumptions and shown us that our understanding of how stars are born, how they live, how they die, and what strange objects populate the space between them was fundamentally incomplete. We are at the dawn of a new era in astronomy. The textbook of the cosmos is being rewritten before our eyes, not just with finer details, but with entirely new chapters we never knew were missing. The great telescope is holding up a mirror to the universe, and the reflection is stranger, more complex, and more wonderful than we ever dared to imagine. The question is no longer just what's out there, but what have we been missing all along? What do you think is the most groundbreaking JWST discovery so far? And what mystery do you hope it solves next? Let us know in the comments below.